Proof by mathematical induction. By this, you should know that mathematical induction is a method that is used to prove that statements like P of n is true for all positive integers n, where P of n is a propositional function. Now, there are two main steps that are involved in proof by induction. We have the basis step where we verify that P of 1 is true, and then we have the inductive step where we show that if P of k is true, then P of k plus 1 is also true. Now let's look quickly at some examples. Now the first example that we're looking at is 2 plus 4 plus 6 plus 2n is equal to n into n plus 1. We're going to show that this is true for all natural numbers. So our first step is called the basis step. So the basis step, in this, we're going to show that n equal to 1 is true. All right. So we're going to grab the 2n here. I'll put that here, 2n is equal to, and here we have n into n plus 1, n into n plus 1. So all we're going to do for the basis step is simply substitute 1 for n. Wherever we see n, we put 1. And 2 times 1 is 2. And that's equal to 1 plus 1 is 2. And 1 times 2 is 2. So we can conclude that it's true for n equal to 1. Right? So now the next thing that we need to do is to show that if P of k is true, then P of k plus 1 is true. All right. So first of all, we're going to rewrite the question in terms of k. So P of k would give us 2 plus 4 plus 6 plus 2n. Sorry, should be using k. All right, so plus 2k is equal to k into k plus 1. All right, so that's P of k. So we're going to show that if P of k is true, P of k plus 1 is also true. So I'm going to rewrite this in terms of P of k plus 1. So that's going to be one more number in the series. It's going to be 2 plus 4 plus 6 plus 2k. So the last number for P of k is 2k. The next number after that is going to be plus 2 into k plus 1. We're going to add 1 to the k. And we're going to do that to both sides. So this k, we'll add 1. So it's k plus 1. This k as well, add 1. So k plus 1. And then we add back the 1 that is there. So don't get mixed up because let's see plus 1 twice. There was a plus 1 there before, but we have to add 1 to it for the P of k plus 1. And next we put back the plus 1 that was there originally. All right, so that leaves us now with 2 plus 4 plus 6 plus 2k. And if we were to expand this, we would have 2 into k plus 1. That's plus 2k plus 2 equal to k plus 1 to k plus 2. All right, so what we're going to do at this point, we are going to replace what is here with what we had up here. If you notice, this is the same thing here. And this is saying that this is equal to this. So you're going to take this and replace this here, as both of them are the same based on what we have here. All right, so it's going to be k into k plus 1. That's this part. I'm going to put back the plus 2k plus 2 equal to k plus 1. into k plus 2. All right, good. And if you observe, both sides actually look the same. All right, if you notice over here, we can simplify this a bit. So we have k into k plus 1 plus over here, we can just put 2 outside, end up back with k plus 1, and that's equal to k plus 1 into k plus 2. All right, so based on the space that we have here, let's jump over here. So based on the fact that we have the same thing in the bracket here twice, we can just write it down once. So we have k plus 1, k plus 1 into k plus 2, and that's equal to k plus 1 into k plus 2. So we can conclude in our conclusion that this is true for all natural number. Natural number is symbolized by n, a big N, capital N. All right, I don't want to spell out the word. All right, good. So that's it. See you in the next video. We'll look at another example.